Hey, Cole, put your jackets on. It's really freezing. I should complain to the lecture hall. All right. Very quick announcement. It's really important. For this week, you're doing your quiz number 1. You all know about it. And for next week, it's going to be your lab test 1. Okay. So now you can check your Moodle announcement for lab test 1. All right. For next week, you can see there's a guide. There's a tutorial video about what the expectation is. I also try to send you messages about why we have the strict grading scheme. Look through them, and then you've got issues, talk to me. And then we also got 2 example tests for you for lab test 1. Try them out, and then let me know if you got issues. It's going to be next week, okay? Okay. So now I would like to start with the lecture about a new topic, which we already got hands-on experience in the tutorial, which is about selections. I would like to start with some motivating example why selection can be useful, first of all. And then we'll talk about some what's the meaning for if statements, which is also important to know. And then we'll talk about examples. Okay, learning outcomes, you can read through them. We talk about Boolean data type, which you already knew about from the tutorial video. And we also talk about if statements, and we're also going to distinguish between a single if statements versus multiple if statements. It's really important to distinguish between the two. And then we're going to talk about compound versus primitive statements, and then also some common errors and pitfalls of writing the if statements. Okay? All right. So now, let's go to the first topic. Let's just talk about a very simple motivating example. And especially, let me switch the iPad over here to show you the code very quickly, okay? If you try to look at this block of code, which should not be very strange to you, we have done this for many times. Let's just have a quick look, okay, and then see what's going on here. So we have a scanner over here. Let me use a different color here. And then we have a scanner here. And then we declare a constant called pi, and also we prompt the user for a double over here for the radius, okay, right? We just say next double over here. And then we simply try to calculate the area no matter what value the user will give to us, as long as it's a double value, okay? And then we simply print out what is the circle, what is the radius the user just entered, and what's the area of that, right? According to the calculation over here. So this is the calculation for the area, given what the user entered from the keyboard, okay? So now if you try to look at this fragment of code here, you can see that every line will be executed unconditionally, which means you will just execute it every time, from top to bottom, with no all conditional, unconditionally. So now what I want to draw your attention to is, they are very, very often you want to make selective actions for your program, which means a very typical case is like this. If the user's input is valid, I'm going to do some computation. If it is not valid, I'm going to do something else. For example, give an error message to them. Okay? That's kind of selective action. Let's see how disastrous it could be if you don't have selective actions. Let's say for this particular fragment of code we just talked about, if you're lucky, let's say if the user simply enters something that is valid, right? So which means over here, next input next double over here is going to be, for example, 3. In which case, you're going to store 3 into this particular variable. And then you'll calculate the area for the circle accordingly, right? That is okay. But what's really the problem? The problem really is, let's say you have another run of the same fragment of code. What you will have is, let's say now, this time, when you say enter the radius of a circle from the user, let's say they enter -3. Conceptually, a circle should not have any radius that's strictly less than 0. We know that very well. So you shouldn't really go ahead and compute the circle area as before, as in the previous case. So now, however, according to the logic of your current code, so now input next double over here is going to be -3 because we just prompt the user, and user enter -3. And then -3 is going to be stored into this particular variable, and then we still actually go ahead and compute the area for the radius using -3. That is where we got a logical error, right? Okay, that's a very typical example where you want to do some error handling for your program. You want to say, if the input is valid, I'll go ahead and do some other computation. Otherwise, print out an error, okay? It's a very typical scenario. If you look at the slides, that's exactly what I try to illustrate to you. You can try them out, actually, on the Eclipse. Okay, so now these are the two cases we just talked about. So we do need selective actions between valid inputs versus invalid inputs. The second motivating example, which we're going to go over also in detail when we talk about the meaning for if statements, is simply to say you have an integer input from the user. You want to say something about the integer. Is the integer negative, 0, or positive? For example, you got at least three possibilities. So these are another scenario you want to handle, okay, by your program. But you can easily do that by using if statements. That is why it's so important to understand them well. Okay, so here, for example, you can see if the user enter 5, you're going to say you just enter a positive number. If they enter -5, you say you enter a negative number, right? You can see that the response from your program is different depending on what the input is. Okay? Okay, so now this is, you know what? This part is only just some English words about informally what we would like to achieve by the if statements. Let me go directly to the syntax about if statements and talk about their meaning a little bit more formally. And then we'll see a variety of examples to really clarify. That's kind of the plan, okay? Okay, so now, before we talk about the if statements, it's really important to introduce another data type. And we do talk about data type back in the elementary programming lecture. Data type, basically, whenever you want to declare a variable, you have to give a data type. And the data type we have seen so far, int, double, float, char, or string, right? So the data type for the variable tells you what kind of value it can store in that particular variable. If you try to store any value that is incompatible with the data type, it's going to be considered as a type error. Okay? That's something we did in the elementary programming lecture. Similarly, for the Boolean data type. And the Boolean data type is actually incredibly easy. This is all you have to think about intuitively what Boolean really means. You basically want to characterize a condition which can be either the case or not to be the case. When it is the case, it's called true. When it is not the case, it's called false. Okay, just true and false, as we said in the tutorial. Let me just, the easiest way, for, true and false. So these are the only two allowable literals for Boolean data type. Okay. The easiest way to write Boolean expressions by using relational operators. Let's just see some example, and then I'll clarify just one syntax with you together. Okay, we talk about basically you want to compare how you do in math and how you do in programming in Java. Okay, it's actually quite straightforward. Let me just do one example with you. So let's see, mathematically speaking, you say less than or equal to, but in Java, you're going to say less than and then equal, right? That's how you did it. And then it should be quite easy for you to judge whether a particular relation should be true or false. That's also something you're expected to know for the quiz this week, okay? Just to remind you. For example, if you have, let's say r, the radius being 5, 5 less than or equal to 5, you should easily tell it's just true, right? You can also try the different various kind of relational expressions, okay? That one is quite easy. You can also do less than, larger than, is just the same. You can also do not equal to. This is the part I would like to give you a little bit more attention, okay? This one can be a little bit confusing sometimes. So now, let me just switch to iPad and show you one example right away, okay? Let's say we got 3 integer variable x, y, and z. They simply to be set a value 3, 4, and 4, okay? So these are the 3 variables we talk about. We got 3, we got 4, we got 4, okay? Let's talk about how we can evaluate a relational expression. The explanation mark, as we talk about, is called the negation operator, which means whatever result you have already, you're going to negate it. If the result is already true, negating true means false. Negating false means true. So now, when I say, conceptually, when I say x is not equal to y, what is x? X is 3, and y is 4. When I say 3 is not equal to 4, is it the case? It is, so it will be true. Okay? And similarly, let's do another one. I have y over here being 4 and z over here also being 4. So now when I say 4 is not equal to 4, is it the case? It is not the case. So it should be false. Okay, we are pretty much comfortable with this. Now, let's try to think about an equivalent way of writing things. They are completely equivalent. You can think about whenever I say x not equal to y, it's the same as, why don't I simply compare x equals to, is equal to y first, and whatever result I get, I will simply just negate it. Or, okay, so let's try this one here. So now let's say the same value. X is 3 and y is 4. 3 is equal to 4. It is not the case. So which means just for this part over here, I'm going to get false. And then apply this negation there, is going to give me true. So I got the same result. Okay, so these two ways of thinking is completely equivalent. Which one to use is completely up to you. Okay, we'll simply say it is not the case that x is equal to y. Let's do one more example. Over here you can see y over here is 4 and z over here is 4. Okay, so now 4 is equal to 4. It is the case, so this will be true. And then we apply the negation over here, so not true is going to give us false. So you also get the same result. Okay, questions? Okay, it's just two different ways of writing the same thing. Okay, you should really know both, especially when you are given questions to read about the code. Yes? Yes, the exclamation mark, basically you can think it this way. Whenever you have exclamation mark over here, it's a unary operator, which means only one operand to be expected. You can think about whatever you put over here, okay, you can put something over here. Whatever you put is going to be a Boolean expression, which means this thing here is going to be either true or false, and they just negate it. Okay, that's how you do it. We'll see more example about negation. Maybe there's another example today, okay, a little bit later. Okay, that's about the relational operation here. Okay, you can just see more example in the slides. Okay, so now let's talk about the syntax, which I did briefly touch upon in the tutorial video. Let's be a little bit more systematic this time. Basically, you have to know what kind of structure for the if statement you can write, and which one to choose is completely up to your judgment. Let's see which one is actually more suitable for your application. So what I would like to do is, let me just start from the slides animation first, and I'll show you on the iPad and show you example for each case. The easiest, the simplest, the minimum if statement you can write is just a single if statement. That's it. Okay? Or you can have an else if, you can have two else if, you can have as many else if as you like. They are optional. And then finally, you can optionally have an else part or without an else part. Those are also optional, right? Again, let me say that again. The easiest if statement you can write, the simplest one, is just a single if statements. Okay? And then you can choose to have as many if, else if as you want, as many as you like. It can be none. And finally, you can also choose whether you want to have an else part or not. That's also optional. The only part that's compulsory is the if statements. Okay? That's about the syntax. Now let's talk about the different cases over here, right? So we're going to talk about one more thing to say. Let me emphasize that, and then I will give you some contrast a little bit later after we talk about the syntax. When you see the syntax over here, where you have if, as many else if as you like, and also some else, the whole thing over here is called a single if statement. There's only one if statement over here. I emphasize it's only one rather than multiple. You will see the difference later because the behavior between single if statements and multiple if statements are different. I'll give you an example a little bit later. I just want to emphasize that to you in the beginning. So now let's talk about for a single if statement, what cases can you have? Let's talk about it, okay? You can see over here, this is exactly the syntax I just presented to you. Okay, I'm going to use that to tell you how you can see the meaning. Okay, let's see case number one. Let's say we have a Boolean expression over here. It can be any expression as you like, as long as it returns either true or false. And then let's say we are lucky. The very first one, Boolean expression one, is simply just evaluate to true. So what does that really mean? Let's see a little bit flowchart. Flowchart is not really required for you to draw for this course, but I would say maybe only in the beginning, when you're not so sure about the meaning for if statements, feel free to draw a flowchart. It's only just a way to help you. Otherwise, you can just understand by programming. Let's see this. If I only have, let's say I got so many if, else, if, else, if, else. However, the very first Boolean expression is already true. So what does that mean? That means you're just going to go into this particular branch and execute whatever that's inside. And all the rest for the single if statement will just be bypassed, which means you just ignore them. Okay? That's what it means informally. Let's have a look at the flowchart. Okay? I'm going to use the pen to highlight the flowchart over here. Let's see here. We start with our program over here, and then we simply have a diamond simply means decision point. We are checking to see whether Boolean expression 1 over here is true or false. And in this case, we are lucky. It's simply just true, which means when it is true, we're going to follow the true branch, and then we're simply going to execute all the statements inside the if statements. And then after that, we'll go all the way. You can see we bypass all the else if and else branch, go all the way to the end. That's kind of the path for the if. If the very first if branch just is satisfied. Okay, let's see an example right away. Let's have a look at this fragment of code over here. Okay, let's see. We have if, else. We do have it, and then we do have Boolean expression for each one of them. You can see I less than 0, I less than 10, and also I is equal to 10, and also else. Okay, let's say I is now just set to -4. Okay, let's see exactly how things will be executed. Because I is simply equal to -4, the way program will be executed just from top to bottom. This is the flow. So we're going to simply check this first condition over here. I less than 0, which means I is -4. -4 less than 0 will give you true. That means this branch over here is already true. We are simply just going to execute whatever is inside this particular branch over here. So we're going to print out I is negative. And so I is negative, it's printed out. A very common confusion is you might still go on to try other branches. That's wrong. Because you try this, what I'm doing now as follows will be wrong. Okay, I'll just use a different color. If you thought you should still go ahead and go to the else if branch, and there you see, oh, I is -4. -4 less than 10 is actually also true. So you would think you should still print this out to say I is less than 10. No, this is simply just wrong. Because as soon as the very first branch whose condition is satisfied, it just executes the corresponding part. All the rest for the if statement is ignored. Okay, it's a very important principle to remember. Okay, so now it's simply not going to be the case. So you can see else if, else, they're simply bypassed. Okay, that's the first example. Is it clear? Okay, just remember the very first branch will be executed, just the first one, that's satisfied. Okay, let's now go to the second case over here. Let's say we are not lucky for the first time. So what we have is like this. Let's say the code flow goes like this. We try to evaluate this particular Boolean expression over here. However, it returns false, which means we are not going to execute whatever that's inside. We are not. So that means we have to go to the next branch. The next branch, the second branch will be the else if. Let's say we do have it. So now when we go to the else if branch, we're going to evaluate Boolean expression 2. Okay, and now we also have a decision to make. Either it will be true or false. If it is true, we're simply just going to execute whatever that's inside that particular branch and bypass the rest of the if statements. Okay, so let's say for this particular case number 2, we say that false for the very first Boolean expression here. That's why we are checking the second one. Let's say for the second one, evaluate to true, let's say. And then that means we're going to execute whatever that's inside this particular second branch. And then the rest of the if statement will just be bypassed, the rest. Okay? Now let's see how this can be reflected on the flowchart. Okay, let's try to understand that visually as well. Again, I'm going to use the highlight to show the flow. So we start with our program over here, and then we try to check this particular first Boolean expression over here, Boolean expression 1, which is this guy here. And we say that it's going to be false in this case. If it is false, we're going to go to the false branch over here, right? That means these two statements are simply not executed. And then we're going to have a second decision to make, which is this Boolean expression 2. And then whether that will be true or false. In this case, let's say it is simply just true. If it is true, that means we're going to execute these two statements inside, so which is corresponded here is true, execute this, execute this. After that, we're simply just going to go all the way to the end by passing all the rest of the else if branch and then go to the end. Okay? Make sense to you? Okay? Let's see if we got any example over here. We do. Let's see one example over here, which will correspond to exactly what I should just show you on the diagram. Let's see over here, I have I being 5, okay? And I have a single if statement. I got if, else if, and else is a single if statements. Let's see how it can be executed. So now when I evaluate this I less than 5, 5 less than 0 will give me false, right? So this part is going to give me false. That means this part is going to be bypassed. We don't execute it. And then we're going to evaluate the Boolean condition for the else if part, which is I is 5. 5 less than 10 is going to be true. So this is the first satisfying branch for us, which means we have to execute whatever that's inside this particular branch over here. So that is why you see I is less than 10. So now the question is, should we go on and evaluate other branches? No, we shouldn't, right? Once you see the first satisfying branch, all the rest will be ignored. Okay, that's the second example here. Okay, let's see the next one. Let's see, we are not so lucky, right? It is very possible all the if branches you specify simply don't satisfy. Oh, sorry, all the if branch condition you specify are simply all fail, all false. It's possible. So it's simply possible when you check this particular first condition here, it simply gives you false. So you bypass this guy here. When you try to evaluate the second one, it also gives you false. So you also bypass this guy here as well. And you go all the way to the end, let's say until Boolean condition n. That also gives you false. And then you also bypass this. Okay, it's absolutely possible. So how does that correspond to the diagram? Let's say I have a quick look. It's basically like this. You start your program like this, and then for every Boolean condition you're trying to evaluate, you simply go for the false branch. And then try the second one is also false, 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 all the way until you go to the else branch, if there's any. Okay, that's also very possible. Okay, so now let's see one more case. So now case number 4. Case number 4 simply means we got all the branches over here. Let me use a better color here. We simply got all the branches being false for us. In that case, we may have to rely on the else part. You can think about the else part is basically just like a placeholder. If all the previous conditions you checked happen to be just false, that means you have to simply just go to the else part and execute whatever that's inside. We call that a default case, which means there's always something for you to do. Okay, it's optional, but it's called default. Okay, default, which means all the previous branches simply cannot be executed. We just go to the default case. Let's see one example over here. So now, example number 1. Let me draw your attention to here. We do have if, we have 2 else if over here, but we don't have an else. That is okay, because the else branch is simply just optional. But that simply means if you're simply unlucky, let's say this condition is false, this condition is also false, this condition is also false. You just got nothing to execute. Okay, let's see if that's the case for here. So let's say over here, I is simply 12. 12 less than 0 will give you false. So we bypass this guy here. And 12 less than 10 will also give you false. So you also bypass this statement over here. And let's say over here, 12 equals 10 is also false. So you also bypass this guy here. So it turns out all the statements inside the 3 branches are all bypassed. So you got nothing. So that's why the console output is simply just empty. right? Okay, it's also very common. Okay, so now let's see another case where you do have an else branch. Let's see this guy here, right? You can see syntactically speaking, the difference between these two examples is you can see this guy here, they do have an else branch, which means you always get something to execute if all the previous branches simply fail to evaluate to true. Okay, let's have a look. Let's say we got over here 12. 12 less than 0 will give us false. So we bypass that. And 12 less than 10 will also give us false. And we also bypass this. And 12 equals 10 will also give us false, which means we also don't execute this guy here. However, since we do have an else, again, this is called the default. When all the previous branches simply don't get evaluated, we're just going to execute whatever that's inside the else branch. Okay, that is why you see this output over here. Okay, so now I have seen many examples already. So now I want you to really make sure you understand what's really the minimum if statement you can write, and how can you have one single else if, multiple else if, and also either with the else or without the else. So these are all the cases you may have. Which one should you choose is completely up to what you need for your application. So what I can do the best is to show you many examples in the class so we can just study them together. Okay, that's exactly what we will do. Okay, so now let me just go over a little bit on the slides. We have covered many examples already on the slides, so we can just go to the new page. And this diagram here, I will encourage you to look at that a little bit just for the simple example. When things get a little bit too complicated, this diagram may not be so useful, but when you're learning from simple example, the flowchart can work, will actually help. I also make a PDF version for that on the lectures page. You can also look at that. Okay, so now we have seen, so this slide here, basically it's just like a textual summary of all the examples we have seen. So I'll leave you to read that. Okay, it's just an informal description about how the if statement should behave at a runtime. Okay, we have seen this example already. Okay, we also have seen this example already. Okay, this one as well. Okay, we have just done that on the iPad. What I would like to do, this one is simple. Okay, so now if you look at this fragment of code over here, so we have if the radius is larger than or equal to 0, that means we're going to print out the area, compute the area and print it out. You can see we only get an if statement without an else, right? Whenever you don't have an else, this is how you can think of it, what's going on over here. You can think about it's as if you simply have the following code. You can see that you still have the if block over here, but the else part simply just do nothing, just nothing inside. It's as if you do nothing when the if statement, the branch is not satisfied. Okay, that's this just a simple equivalence show. Okay, let's look at it. This one is more interesting. Okay, well, I would like to show you that on the iPad. Let's say we are trying to calculate from your row marks, numerical row marks, to a letter grade, for example, right? What I want you to show you is like this. Let's say we already got an integer variable called score. Let's say we got that already. Okay, and then what we have is we say that if the score is larger than or equal to 80, we print out A. If that's larger than or equal to 70, we print out B. If that's larger than or equal to 60, C, and otherwise nothing is satisfied, let's say we print out F. Okay, it's a simple program over here. Okay, this code is good. What I want to show you is you might have another way to write it. Depends on what you prefer. And the way I'm going to rewrite it is very similar to the tutorial video I showed you for last week. Okay, let me give you a little bit insight. Think it this way. A very simple question to ask yourself. At the runtime, when will I actually evaluate this condition? When will I do that? Am I always going to evaluate this condition here? I would say always evaluate it at the runtime. That's the question. Okay? The answer should be not really always. Why? Because as we explained before, the way that branching conditions are going to be evaluated at runtime is as follows. you always evaluate the first one first at the top. If this one is already false, you will bother to go ahead and evaluate the second one. Okay? So that means always evaluate at runtime? No. Only if the previous one, for example, score larger than or equal to 80, only if score larger than or equal to 80 evaluate to false. Okay, that's a very quick reminder of previous slides. Okay, so now let's keep this in mind, which means every time when you're trying to evaluate this particular branch condition over here, of course, again, when will you evaluate, let me use a different color, when will you evaluate this particular green condition over here? You only do it when score larger than or equal to 80 is false, and also when score larger than or equal to 70 is also false. You only do that only if both are evaluated to false. Are you going to evaluate this condition over here? Okay, that's a very important insight into this if branch. Having this insight, we can rewrite the program in the following way. Okay, let me show you. Okay, let's say I don't really like the else if over here. Let me just use if and else, no else if. Okay, this is what I would do. Let me just be a little bit more visual over here. Let's say the very first condition, I'll make it green. Okay, that's the very first condition over here. And let's say the second condition over here, I'll make it blue. The third condition, I'm going to make it, let's say, pink over here. Okay, we got 3 branching conditions for you to choose from the if-else-if statements. So now, let's see the following. Okay, so what I would do is, let's say I start with if, and then I'm simply going to put a green one over here. Okay, score larger than or equal to 80, right? If it is the case, I'm going to say you got A. Otherwise, you got something other than A, right? In that case, what should I check? I can check again to see, well, given that I know that the green one is not satisfied, I can now check the blue one. So inside the else branch, I can do the following. I can say if, let me put the blue one over here, the score larger than or equal to 70 is true, that would mean you actually got B over here, right? Otherwise, you got something other than B. Okay? And then in the else branch over here, what can I check further? Well, I can check the pink one over here. So I would say if the pink condition over here, I can do over here, let me just use that over here. If the pink condition over here, score larger than or equal to 60, if it is true, I'm going to give you C. I'll put C over here. Okay, otherwise, if it is not C, it's going to be F. Okay, let me just write it more properly here. So it's going to be F. Okay, it's just a rewriting over here. So rather than having if, and else, that's the left version. What I just hand wrote over here is simply say if the green one is true, I give you letter grade A. Otherwise, I'll check further to see if the blue is true, I'll give you B. Otherwise, I check further to see if the pink one is true or not. Right? That's kind of equivalence. Again, between these two versions, which one to choose is completely up to you, since they mean the same thing. Okay, it's completely up to you. Okay, this particular one over here, this particular the right-hand side version is what I showed you in the tutorial video in the past week about the back application. Right? We say if this particular error is the case, if the input, let's say for the transaction type is actually valid, I'll go ahead and prompt the user further. Otherwise, I will actually give you some error message. If the transaction type is correct, I'm going to prompt the user further about the amount, and then I'll check the various conditions about the amount too. Okay, that's something you can relate to for the tutorial video. All right, that's about this particular example over here. You can also go through them. Okay, and if you would like to try the flowchart, feel free. Okay, but if you're clear about the meaning, you're fine. Okay, so now let's have a look at this example over here. On Wednesday, I'm going to show you some contrast example, but let's focus on this one particularly. What I want to show you is this. If you look at this example over here, So now, you can see that we do have a single if statements. We got if, we got else if, we got else if. And there's no else, okay? Now, here's how you think about this particular example, okay? As I said before, it's very likely you might have a score that is going to make this condition false, and make this condition false, and make condition false, right? For example, what about the score? Let's think about this. If I have a score, let's say 50, okay? 50 is definitely going to make this condition false, right? 50 larger than or equal to 80 will be false, and also 50 larger than or equal to 70 will be false, and 50 larger than or equal to 60 will be false. So now, according to how I write the program over here, am I going to receive no letter grade if my score is 50? No, right? Why? Which line actually does something for me? The first line, okay? I want you to look at the first line. You can see that the first line over here, string letter grade over here, I say is going to be F by default, which means I assume every student will get F to begin with. However, if you're able to get larger than or equal to 80, I will reassign the letter grade to give you A, okay, and etc. So now, I would like to rewrite this particular program in a slightly different way to show you what if you want to have an else part, okay? What about I have over here? Okay, I'm going to write it here. Let's say I still have string, I will say LG for letter grade. Let's say initially just empty, which means this is not a valid letter grade, okay? And then I can say, I'll say S for the score. If the score is larger than or equal to 80, in that case, I will give you LG should be reassigned to A, okay? Easy. And then I can say else if the score is larger than or equal to 70, I can reassign that to B over here. And then I can say also else if the score is larger than or equal to 60, and then LG is going to be assigned to C. Now, question for you. The second version I'm writing, would it work if I simply don't have the else branch? It wouldn't work. Well, not. Negative. Because let's say we still use the score being 50 over here. So we know that 50 larger than or equal to 80 will be false. And this 50 larger than or equal to 70 will also be false. And 50 larger than or equal to 60 will also be false. Which means none of them will be executed. They were all bypassed. Which means nothing will be reassigned to LG. And will simply keep the empty string. So that's a logical error. Which means if you try to write this Java code in your Eclipse, it is going to compile. And it is going to run. It will just give you the wrong answer. So now, how can we fix this? Well, one way to fix it would be, of course, you can simply do the version 1. You simply give F to be the default. Or I can simply just add a else branch. I can say else over here, and then I can say LG is assigned to F. So these two flavors, again, is completely equivalent. Which one to use, again, is up to you. Okay? Okay, we'll just go over many examples to show you different tricks. Hopefully you can apply them as you wish. Okay, so now let's look at something that's also very interesting. Now that we understand very well about the meaning for if statements, I would like to revisit this particular example, which we talked about in the motivation part in the beginning. Let's say we want to improve our circle area calculation problem. We want to tell the user, we want to prompt the user for the radius. If the radius is negative, we want to give this an error. Otherwise, we go ahead and calculate the area, right? So now I want to show you something interesting. I want to show you two different ways of writing the if statements. Okay, let's see that. Okay, let's see the first one. The first one is easy. The first one, let's say we still prompt the user for an input. So we declare the scanner, and then we prompt the radius to be a double value, right? You can see that radius over here. And then this is what we do. For example, we say if radius is less than 0, then we're going to print out the error to the user, right? We are not going to do any computation. Otherwise, the else part will do the area calculation, okay? That's the first version, okay? Now, let's play a little bit game about logical rewriting, okay? Over here, you can see that the if branch over here tells you what the condition is for an invalid input. So what I want to do is, what about we switch the order a little bit to say, I'm going to say if the radius is valid, and then I'm going to do the computation. Otherwise, I print out the error. I kind of swap the order of the selections, but the conditions to be checked are just the same. That's something I want to show you. Okay, let me show you on the slide first, and I'll compare with you the two examples side by side. So now, let's think about the second version. The second version goes like this. We still declare the scanner as before, and then we also declare a radius read from the user. But now we're going to say, well, if the radius is valid, which means it's larger than or equal to 0. And one thing to actually mention to you, okay? When I say things about valid and invalid, thinking this way. This is some logical law, which I'm going to talk about on Wednesday, but just thinking this way. Let's say I got radius, okay? I got radius being double. We know that it will be considered as valid if the radius, let me start with the invalid. It will be considered as invalid if the radius is less than 0. Now, logically speaking, how can I write a condition for if it is considered valid? That's the question. So how can I say valid? Well, logically speaking, this is what we can do. You can think about valid simply means it is not the case that it is invalid, right? It is not the case that it is invalid, right? If it is not valid, it must be valid. If it is not valid, it must be invalid, right? It's kind of negation of each other. So now, when I say it is not the case, when we talk about negation just previously, if it is not invalid, which means it is not the case, radius is less than 0. And now we know very well from the high school or elementary school math, what is the negation of this when I have less than? It should be larger than or equal to, right? Just flip the sign, basically. Okay, so this is equivalent to radius larger than or equal to 0. So now, let me highlight again. So here, I'm talking about two conditions over here. When I talk about valid condition, I say radius larger than or equal to 0. And when I talk about invalid condition, it's radius less than 0. And now, because they are kind of logical negation of each other, so we can use them in different orders in the if statements. Let's see how we can apply them. Okay? It's a very important logical observation from the operator, so hopefully you can apply that. Let's see the two versions we have over here, okay? And then we'll do examples together, okay? Now, let's just have a look at the first one, which you might be more comfortable with. Let's say the first one. So we have, let's say, if the radius is less than 0, so that's for the invalid inputs. Okay, let's just try two different inputs over here. Let's say I try input number 1. Let's say the input is simply just 9, which is valid. Let's see how the execution flow will go. So that means the user is going to give us, let's say 9 over here. And then 9 is going to be stored in radius. So that means 9 less than 0 will give us false. False, that means this part is not going to be executed. And then we're just going to execute these lines and calculate the circle area, right? So that's a case where you got valid input. Okay? Now, what about the case where you don't have valid input? Let's use another color here. Let's say the user gives us -5. So what does that mean? If they got -5, that means input on next double is going to give us -5. And then that means -5 is going to be stored in the radius. So now let's try to evaluate this particular run very carefully. Let's trace it. When I try to calculate this, so now it means -5 less than 0 is going to give me true, right? That means I'm just going to execute this particular line only, but the rest is just going to be bypassed. You can see for the two cases, it's exactly one way or the other, not both. Okay? The orange one will go to the second branch. The blue one will go to the, let's say it again. The blue one will go to the second branch, the else branch. The orange one will go to the first branch. Okay? Now, let's now see the second version over here, in which I simply just switch the condition to be checked. Rather than saying if something is invalid, I'll say if something is valid. What should I do? Okay, and we'll prove that the two programs are exactly equivalent. So now what I will do, let me just draw your attention to this. You can see the condition we are checking now is radius larger than or equal to 0. That means we are checking to see if it is valid, let's do something useful. Otherwise, print out the error. Let's now see how the two programs can be traced. Again, let's use the same color. Let's say we test case number 1, 9, which is valid, right? Let's try that. The user is going to enter 9 over here from the keyboard. That means the radius will be storing 9. And then 9 larger than or equal to 0 is going to give us true. That means this part here is going to give us true. So we are just going to execute these two lines over here, whereas this part here is bypassed. So if you compare in the first version, exactly these two lines were executed, and over here is also these two lines were executed. Just arrange it in a different order for the if statements. Okay? Let's now see another one. Let's say it's -5, okay? Which should be considered invalid. Now, if it is -5, that means the user is going to enter next double over here being -5. Okay, that means -5 will be stored into radius. Let's try to check the if condition. So what we get is over here, I'll write it down. -5 larger than or equal to 0 will give you false. That means this part over here is just going to be bypassed. So we are bypassing the same lines of code as in version 1. And then we're going to go to the else branch and then execute this particular line. So we're executing the same line as in the first case. Okay? Now, again, these two versions are completely equivalent. The most important thing is for you to do such logical analysis over here. Let me say that again very quickly. We start with some condition over here being something being invalid. Okay? Now, for the condition something being valid will just be the logical negation for that. And then we just apply some rule over there. I'll summarize the rule for you a little bit later in the course. Okay? Okay, let's have a few more minutes. Okay, maybe 3 minutes. Okay. So now I want to show you some interesting example over here very quickly. And let's have a quick answer over here. Okay. So now let's consider two programs over here. All I need you to tell me is, are they going to behave the same at the runtime? Okay? The first program over here, we got if, else, if. If, else, if is a single if statements. And then I larger than or equal to 3, and I less than or equal to 8. We talked about number interval also in the previous tutorial. Hopefully you're reasonable okay with that. The second program over here is the same condition. You can see I larger than or equal to 3, and I less than or equal to 8, the same condition. The difference is, the second version over here, we got two if statements, right? You can think about the first if statement, you just got the minimum structure, just the if statement over here, okay? Just the if statement. And the second if statement is simply just if statement itself. So now the question is, are they going to behave the same at the runtime? That's the question. Okay? Let me just, I'll let you think about it, okay? I'll definitely tell you the answer on Wednesday, but let me just give you another one here. Second question, let's compare again a very similar program over here. Again, the first version is a single if statements. And over here we got I less than or equal to 3, and also I larger than equal to 8, the two conditions over here. And then repeat the same two conditions over here, but now we got multiple if statements. First if statement over here, and second if statement over here. And do they behave the same? Okay, that's kind of the two questions I have for you. Okay, so now let me see. Okay, I'll stop here and I'll continue from here on Wednesday.